All right, so today we're going to talk about taking yesterday's lesson of what properties a parallelogram has, and we're going to kind of work in the reverse order, talking about how do we know if something is a parallelogram. So we're going to have a shape, we have to determine whether or not it is that parallelogram. And so there's 5 main ways that we can determine whether or not we have a parallelogram. And so as we're looking at this, one of the ways that we can do that, so we're starting with quadrilateral, and we want to work towards parallelogram. So in this first statement, it says both pairs of opposite sides are parallel. So what's really important here is that both sets of opposite sides need to be parallel. So if we take a look at kind of a picture down here, so if I draw in a picture, looks like a parallelogram. Now, just because it looks like one doesn't mean it can be, or that it is. So I would need to actually see markings that tell me this side is parallel to this side, and then the other pair of sides are parallel as well. So we should see these 2 sets of arrows given in the picture. If I don't see both sets of sides parallel, I cannot conclude that it's a parallelogram. But if both sets of sides are marked, then we're good to go. Now the other thing we can see is both pairs, and again, both pairs of opposite sides are congruent. So if I get a picture and they show me that the top and bottom are congruent, and they show me that the left and the right are congruent, both pairs of sides have to be congruent to each other. If I don't have both pairs, I can't say parallelogram. It's got to be both sets, and I've got to see the markings, or they've got to tell me like this side's 5 and this side's 5, this side's 10 and this side's 10. So they might not mark, they might just give you labels. And so then just understanding that's what we're looking at. Okay. We also have the next one here, which is both pairs of opposite angles are congruent. So both pairs of opposite angles. Now in this case, again, we might get a picture, and if they show us, like, let's say this bottom angle is 110, this one's 110, this one's 70, this one's 70, we can see that these opposite angles are congruent, these opposite angles are congruent, and since both sets are, we can conclude that it's a parallelogram. Or they might do it with the markings, so they might just say like this angle is congruent to this angle, and then this angle is congruent to this angle. If you can see that both pairs of opposite angles are congruent, then you're good to go. Now the next one is a little bit trickier, and it's one pair of sides. So we're looking at one single pair of sides, and what we're looking at is that they're both parallel and congruent. So this one's a little bit trickier, but basically what we're saying is if I have a picture here, if they tell me that one set of sides, so let's say the top side is congruent to the bottom, and they tell me that this top is parallel to the bottom. So I have to have both sets of markings on the same 2 sides. So top and bottom are congruent, top and bottom are parallel, then I can say that they're a parallelogram. What's tricky about this one is if they try to do something like this, where they say, okay, here's this, we got this side's congruent to this side, and this side's parallel to this side. Well, that's not the same set of sides. One set of sides is congruent, one set of sides is parallel, but it's not the same set of sides that's both. So it's got to be really you got to be really careful with that one and make sure that you understand both parallel and congruent has to happen on the exact same sides. And then on the last one here, diagonals bisect each other. That's the exact property that we talked about yesterday. So if I have a picture and the diagonals are drawn in, and maybe they say this side is congruent to this side, and they say this side is 10, this side is 10, well, I can see that both sets of diagonals are cut in half, and so then that can be a parallelogram. So what we're looking for is any of those properties we had before. If we can show those, then we know we have a parallelogram. Okay, so if we look at some examples, they're going to give you a picture of a shape and say, is this a parallelogram or not, and then kind of explain. And so if we're looking at this first one here, call this number 1, we notice that top and bottom are congruent, and then they also say that left and right are congruent. Well, since both sets of opposite sides are congruent, yes, this is a parallelogram. The reason both pairs of opposite sides are congruent. Okay, so both sets of sides had to be congruent to each other. In the second example, let's call this one number 2. So I see the top is congruent to the bottom. I see that the left is parallel to the right. Now, both sets of sides are not congruent, just the top and bottom. Both sets of sides are not parallel, just the left and the right. So those two things alone won't tell us enough. Now, there was that one that said one pair of sides are both parallel and congruent. But if I look at this, I have the top and bottom congruent, the left and right parallel. For that property to work, I would have to have top and bottom congruent and top and bottom parallel. Or left and right congruent, left and right parallel. It's got to be the same set of sides for both. So in this case, no, we don't have a parallelogram. In our third example, we'll do this one down here. Now this one's a little bit tricky because if kids are going really quickly here, they tend to see, okay, 116 and 116, those opposite angles are congruent, this is a parallelogram. But you got to be careful here. Both sets of opposite angles have to be congruent. And so when I look at this picture, I have this 117 degree angle on the outside. And we've talked about so far in this chapter that if I have an exterior angle, that's supplementary or adds to 180 with the inside. So if the outside is 117, the inside would have to be 63. And now if I look at these opposite angles, they're not the exact same, so this is not a parallelogram, even though it looks like it could be. And then if I look at my last example, so number 4 over here, we see that the diagonals are drawn in, and we notice that this piece and this piece are marked congruent, so that diagonal's cut in half. And then the fact that the other two pieces are both 9 means the other diagonal's cut in half, and so this would be a yes, because diagonals bisect each other. Okay, so if you're going to say yes, it's a parallelogram, you need to be able to tell me why. So yes, because opposite sides are congruent, or yes, because diagonals bisect each other, or it's just no, I don't have any of the information I need, so it's just not a parallelogram. Another one, if they give us a description. So it says in quadrilateral WXYZ. So first of all, just draw a quadrilateral WXYZ. So just go around the figure. And it doesn't matter how you draw it, because you don't have to draw it to scale, just draw a quadrilateral. It says the measure of angle W is 42. The measure of angle X is 138. And the measure of angle Y is 42. It says find the measure of angle Z, and then determine if WXYZ is a parallelogram. Now, this goes back to our first section of chapter 7, which said that in a quadrilateral, all 4 angles have to add up to 360. So I'm looking for this angle Z here in the corner right there. And so to do that, I need to take 360 minus the 3 angles they've given me so far, so minus 42, and minus 138. And when I take all of that away, I get a total of 138 degrees. And so what we have here is that this angle that we just calculated is 138 degrees. Well, so if I look, these opposite angles are congruent. These opposite angles are congruent. So yes, this is a parallelogram. Opposite angles are congruent. Okay, so not only yes it is, but how do we know? So we found the missing angle. Opposite angles were congruent, so yes, it was a parallelogram. If you get to a problem like this, it says find the values of x and y that ensure each quadrilateral is a parallelogram. So basically they're saying make sure that we find x and y so that these do become parallelograms. So first thing, if we're looking at this first example over here, I have this 2y plus 12 and this y plus 24. Those are opposite angles. And we know that in a parallelogram, opposite angles have to be congruent. So I'm going to take 2y plus 12 and set it equal to y plus 24. And so when I do that, I can go ahead and solve for y. So if I subtract y over 2y minus y is y, subtract the 12 to the right, 24 minus 12 is 12, and so there's my y value. Now on the other one, we haven't talked too much about this yet, but if this is going to be a parallelogram, that means this top and this bottom are parallel to each other. And so when I draw this diagonal in here, what I'm creating are opposite or alternate interior angles. And we know from parallel lines that alternate interior angles are the same. So that means this 4x has to equal 2x plus 18, and then I can solve for x. So subtract the 2x over, I get 2x equals 18, and then x would equal 9. Okay, so we might be bringing some stuff from previous chapters back in, and with parallelograms, those alternate interiors show up a lot. Now in the next example here, so in our second example, notice now we're talking about the diagonals, and we know that if this is a parallelogram, these diagonals should cut each other in half. And so each of these pieces should be congruent, meaning I can take 3x minus 7 and set it equal to 62. And then I can solve that for x, which you guys can do. And then I would take my 4y plus 12 and set it equal to 60. And then again, I would solve for y, which you guys can do. So the big thing here is just understanding how to set up the equations. Am I setting them equal to each other, or are they consecutive angles and add to 180? So you just have to kind of figure out what's the relationship, set up the equation, and solve. Okay? On this one, again, it's just kind of one of those word problems. They're telling us that AB has a length of 5, CD has a length of 5, and then it says angle A is 130, and angle D is 50. Now what this tells us is that AB and CD are congruent because both sides are 5. The other thing that it tells us, though, is that these angles right here, these consecutive angles, add up to 180, which means that the side on the bottom is parallel to the side on the top. And so what ends up happening here is we have congruent and parallel on the same set of sides. So yes, this would be a parallelogram. So sometimes you got to kind of work with the angles to get the parallel as well, which you guys can go with. This is just a graphic that just goes over those original 5 ideas that we talked about earlier. And so things to think about here, because we're going to talk about how to do this in the coordinate plane. How do I determine what type of shape I'm looking at? So parallel sides means we're going to need to be able to find slopes. So what are the slopes of the lines? And then how can we compare them? Or show that both pairs of opposite sides are congruent, which means we would need to use the distance formula. Or show both pairs of opposite angles are congruent. Now that one is going to be tough in the coordinate plane, so this is one we're probably not going to use with that type of problem. Showing one side or one pair of sides are congruent and parallel would be both slope and distance. So I'd have to do, for 2 sides, like this top side and bottom side, I would have to do the distance formula to show congruence. I'd have to do slope to show parallel. Or I can show the diagonals bisect each other. So these 2 diagonals bisect each other using the midpoint. So I can show that they bisect using midpoint on each of the diagonals and then calling it good. Now for me, as we look at this example here, what I would suggest doing is if we're trying to determine whether or not we have a parallelogram, because they give us the graph or they give us the coordinates that we can graph, in my opinion, the easiest thing to do is calculate slopes. Both the distance and the midpoints require us to take the points, plug them into formulas, solve, and then get the answer. Slopes only require us to count. So if I want the slope of this top line KL, so slope of line KL, all I've got to do is start at K and count to L. So I start with my up and down. I go up 2, and I go to the right 6. So if I go up 2, that's positive 2, right 6 is positive 6, which reduces down to 1/3. If I then go to its opposite side, I would always do these in opposites. So if I go to the opposite side here, JM, so now I want the slope of JM. Well, if I do the same thing, start at J, count up 1, 2, and then to the right 1, 2, 3, 4, 5, 6, I get up 2 and right 6, which is 1/3. Now notice both of those slopes are the same. That means these 2 lines are parallel. And so then I could mark that in my picture just to remind myself these 2 lines are going to be parallel. Now if I look at the other sides, so maybe I start on the right side here with LM. If I want the slope of LM, again, I'm just going to count. So starting at L, I'm going to go down 1, 2, 3, 4, 5, 6. So I'm going to go down, which is negative, and then I'm going to go to the right 1. And so I go down 6, negative 6, right 1, positive 1. There's my slope. And then if I do the same thing for the opposite side, again, I would always try to stay with opposites. So opposite side would be KJ. So my slope of KJ, if I count down, would be 1, 2, 3, 4, 5, 6. So negative 6 again, and then to the right 1. So down 6, right 1. And then if I notice, these two slopes are exactly the same, which means they're parallel. So this left side is parallel to this right side. And so both pairs of opposite sides are parallel, which means yes, this is a parallelogram. So when you're working in the coordinate plane, this would be my go-to, because all we have to do is count. We don't have to do any calculations. We don't have to do any formulas. We just count from one point to the next, and then we make sure that the opposite sides have the same slope, and if that happens, then we have a parallelogram. So with that, you should be able to complete the worksheet that you get in class or get off of Google Classroom. Make sure you ask questions as you need to. If you're stuck on anything, make sure you check the answer key and have that ready to go when it's time to turn that in.